Alright, so we almost have the SR latch assembled. SR latch that consists of two NOR gates. Why do I say we almost have it? Well, the reason why I say we almost have it is that the inputs cannot be controlled yet, but there is a reason I left it in this state. The simulation is already going. Now we can see both of these probes high, which means there's 5 volts right here. Can we check it? Let's get a multimeter. Grab a multimeter from here, from right there, and can we do this? Connect that line to where the probe is, and the other one I'm just going to copy this ground, copy and paste, and place it right here. Call up the display by double clicking on the multimeter. This is going to be our display. When we simulate that, what does it show? Oh, it shows 5 volts. We open the switch and we close the switch. It always shows 5 volts. What's the reason why I wanted to show you this? I wanted to show you this because, look, this switch, when closed, is going to bring this point straight high to 5 volts. Then why doesn't it go low when I open that? It's disconnected from this 5 volts. This point is disconnected. It is and it isn't, because in the TTL family, when you do not tie the input anywhere to ground or high, it automatically assumes the position of being high. It's just a little thing that I wanted you to know. Okay, but let's just make this thing more controllable. So I'm just going to stop the simulation, and we're going to be able to bring this point up or down, high or low. And I have a couple of resistors, and in this case 10 kilo resistors are just fine. So I'm just gonna get alright, it doesn't matter which. So here, now this point, when we close the switch, is going to be brought to high. But if the switch is open, then it is not tied to high, but it's actually connected through a resistor to low. Okay, so now see, the probe is off. Now we can control this. We'll watch this probe and this switch. Now we control it. We closed it. This point is brought high because we just connected straight to 5 volts. We open it. It is connected through the resistor to the ground only, and it is not connected anywhere else. Okay, so let's just do the same thing to the other input. I'm going to stop the simulation because I'm changing it. There you go. So now we can control the SR latch, and let's see if we can control it truly. So press the run button. The simulation is on. Of course, this thing is going nuts because this is the way of the software telling us that this is the undecisive state since the go. So as soon as we turn it on, it's unpredictable which way it's going to go until we press one of them and tell it where to settle down. So why don't we just tell this to settle down at the Q by pressing the set button? Oh, look at that. It goes to Q. The set button is high. And then no matter how many times I press the set button, it is going to stay set. We can't have this thing more set than it is. We can't have it more 1 than it is 1. It's just we can't have it more high than it is, because there's only one state of high, and it is the 1, which is 5 volts. So now we just have pretty good switch the bouncer. So that momentarily is being pressed. That's all we need to set that to Q. And so to set that to reset that, which means this is going to go off and the not Q is going to come on, we have to momentarily press the R, the reset button. So press it and things have changed. We can set it, momentarily press, or we can reset it. Watch this output here as I keep pressing these buttons momentarily. Yeah, and here. Okay, so well, so we have the SR latch. Let me just get rid of that voltmeter here. Okay. and get rid of the ground. Alright, so let's play with this thing a little bit. What can we do? What if we added a couple of AND gates here? Alright. In this case, we're just going to make us some room by erasing some lines. Can we do this with that? Yeah, I guess we can. If not, we're gonna erase some more lines. Okay, place component, and I already have that selected by having this all groups and the master database. I just type the word and different types of AND gates showed up. This is a 2-input AND gate. Click OK. Just gonna place it anywhere for now and close the choice window. I'm going to double click and clean it up a little bit. So I'm just going to go into the display tab and choose the manual choice of what we want to display, and I'm just going to click everything off. So we have a nice, for the demonstration purpose, nice clean AND gate, and I'm going to copy that because we need two of those. So copy and paste. Alright, good. So let's just align those so this output goes to this input and this output goes to that input. Why not? Yeah, can we make it closer here? Yes, we can. Let's just align things so it's nice and pretty. And I'm going to connect this to here and connect this to here. So now we have that. What else can we do here? Well, what we can do is connect this one of those inputs to let's just yeah, we can do this. Just gonna move it up a little bit just so things are nice and pretty, and I'm going to fix that connection here. That's gonna be nice. Fix that connection right back, and this one we're gonna bring it a little bit down so also is nice and pretty. Okay, so now we're going to connect this here and this here, right? Right. Good. So let's see. Press the simulation button. Okay. Now, see in the software version of this is 14. I'm pretty sure it's in all the other ones. Really, these should be tied high, but we have no connection here. So in this software, this is not recognized as a valid state of high. So it's just going to go. Actually, no, yeah, it's just going to go nuts. So both of these are high right now, but we can't control this thing one way or another. So let's just make things more controllable for ourselves by tying these two inputs to high. What is going to happen is that this is an AND gate, so if we tie this point high, okay, then it is going to pass the signal through. It's just like enabling the AND gate so we can have on the output whatever is on the other input that is not tied high. Okay? Let's just see what happens. Press play, and of course this one now is going to be 1, and if we turn it off it's going to be 0. So whatever is on here is going to be on here. Right? Now it seems to want to work, but we're still not sending the cue. Right, these are the nuances and details of the software. Let's type both of them high so we can have clearly controllable those two AND gates. So what I'm going to do, I'm just going to connect both of them and connect them high. Okay, there we go. Now let's start simulating things. Okay, this is gonna go nuts still. Alright, let's just bring it to one state. There we go. momentarily, momentarily, okay, momentarily press, and momentarily press. Okay, you want me to keep going with this? Let's just stop right here. So what did we accomplish with this? Pretty much nothing as the end result, because it still works as it was, but now we have made it, it became the newer and better version of what we had before. It just has more parts, but the functionality is no different. But we can take it one step further now. Instead of hiding this permanently, what if we control that by a push button switch to make it high or low? So this RS latch, excuse me, would work as RS latch whenever we want it to. And if we don't want this thing to be functional, we are just not going to enable it. Okay. So let's press the stop button here. Get rid of that line. We're going to tie this to a push button switch, and I just happen to have this push button assembly already ready on the bottom here. I'm gonna bring it up. Okay, so now do we have this thing at the right height? I think we do. All right, so basically we're going to tie this high. Okay. And this point is controllable by this push button switch. So when the push button switch is not activated, this connection here is broken or not engaged, excuse me, then this point sits at 0. When this push button is pressed, then this point right here becomes high because we're tying it high. Okay. So let's just connect this point right here to that point so we can control it, so we can tell it to be high or low. Okay, again, I'm going to double click, there we go, just to start the trace right in the middle and connect that right here. Good, so now we're controlling this. When we have both of them high, these points, those should be high. When we have both of them, one of them low, we push this button, and it's going to give us whatever is here, whatever is by controlling this push button, we are going to give this input as high. So it's just like enabling this AND gate and enabling this AND gate both at the same time. And when this is enabled, then whatever is on the other input is going to show up on the output. That's what I was trying to say. All right, let's start the simulation. So what should we see here before we start the simulation? This point is low. So when we apply the high signal here, enable those AND gates, it's going to show a low on the output because this is low. Now this point is high, so we give this high on the other input, it's going to show up high. So the reset is going to be high, the set is going to be low, so the state should remain as it pretty much is by chance right now. Right, let's see. Here. And when we enable this, it's going to get that point. What are we looking for? We're going to have high here. Reset is going to be high because this is high. We're going to have low here because the set is low. So of course that is going to give us the not queue on. Let's see. Oh wow, I just pressed that button. Cool. Now if we open that, now we can just keep pressing that enable button and nothing is going to change because the situation has changed. Now if we depress that button, we are making both of these high. Right? That's an invalid state. Sorry, we're making both of them low. All right, sorry, that's low. So these two are low, so the system is latched. Okay, we can keep pressing that button here. Now, when we press the set button, the queue should go on, the not queue should go off. Let's just press that button. It didn't happen. Why? Because we didn't press the enable button. Oh wow, we're going somewhere with this one here. So let's just press the enable button. Okay. Now we keep pressing this, nothing happens. We release that because most of the time we're going to have this momentarily, but I just don't have two mice at the same time, so I just have that switch. Now we keep pressing, nothing happens because they're both at 0, so set and reset are 0, and if we enable whatever the end gate, the SR latch, then we have both zeros. It is going to keep the previous state, so that's what the latch is. Okay. All right, now we can take it a little bit further, because still, do we really need to have both of these? Maybe in some cases we do, but we still have to manually set one or the other. What if we connect both of them high, all right, and then look what happened. Okay, this thing goes into the undecisive state. So we still have a chance of having this thing both. Oh, come on. All right. Going to have the chance of the whole thing going to the undecisive state. But now we have the RS latch with the enable input. Okay, so this is called the enable input right now. Can we place text? Place text here. We're just gonna put this, we're just gonna call this thing EN for enable, and that is going to be our enable switch. Okay, cool. Now the purpose of this whole exercise is to show that maybe we can just make this whole circuit, remember, one state, high or low. So do we need really Q or not Q? We don't, but we're just going to leave the not Q here. We're just going, let's see if we can just keep one of those states and get rid of the reset, because we just want to have, we just want this whole thing to remember whether we want to have 1 or 0 stored. So we don't need to complement the other one with the opposite. We just don't have to remember that if one is 1, the other one has to be 0. Okay. So let's just stop the simulation and play with this thing a little bit further. I'm going to erase that line here, so this is disconnected. We're just going to play it with this set here. I'm going to press that one, disconnect, and I am going to just put that right aside, the reset switch. Okay. What else can we have? So this is the this is the state of the input that it goes here. What if we automatically reverse them? All right, so that would be placing an inverter. Do we have an inverter here? No. Let's just place component and all groups, master database, type NOT. That's going to give you the NOT gate. So that's the inverter. Place it somewhere else, somewhere and wherever. Double click, clean up the display. We don't need all the labeling showing here. Okay. And that is going to go into this point right here, which means we can just get rid of that line and connect that here. We can also get rid of this resistor because we don't need it. Clean up here. Good. And this goes right to that, so whatever is on this input is going to be reversed. See if we can get this thing without too many squiggly lines. Right here. Okay, this inverter is a little bit, there we go. That's much cleaner. So whatever is here is going to be not here, and whatever is not here is going to be okay. Let's see if we can make this work. Now, we only have one input now and one enable input. So let's press the simulation. Let's see what happens. Okay. Now, at this point, the set is 0, which is going to give us Q0. And the of course, the reset is going to be 1 momentarily when we apply the enable button. So it's going to enable that and latch the latch into this position right here. If we change that switch, it is going to reverse the situation, but only if we press the enable button. There we go. Now we can keep pressing the enable button and nothing's going to happen because we already set that to whatever, nothing else has changed. But now until we press the set button and we enable that. So basically what we're doing here, we are setting this data bit to whatever we want, and we are going to tell the system to capture it at the moment that is set. So this thing can go up and down, whatever. And at some point we're going to say, okay, capture the moment right now. Capture. Okay, so it's good because set is at 0 and the Q is going to be at 0. Okay, so now let's just keep going with this. This thing is going to go up and down, and it happens to be closed, so this is going to be high, and we're going to say, okay, capture at this moment. All right, so now we have this thing captured at the S being at high. All right, cool. So now we know how it works. Do we need this not Q right now? No, we don't, because we know if one is the other one's going to be the other way. So you know what? Let's just get rid of this. Just get rid of this not Q thing here because we just don't need it at this point. All right. So now we have the Q. Now, and we don't now. We can substitute the S for set as with the letter D. All right. D. Okay. D stands for data. So whatever the data is at the moment is going to be captured by the enable pin and is going to show what it is here. So yeah, maybe we can just get another probe here. So I'm going to copy this probe here, copy, and I'm going to paste, and we're just going to right. I'm going to place it right here. So now the D stands at 1. It's going to give us Q1, and we're going to okay. Let's press the play button here. The D is at 0 because it is not connected to 5 volts. It's connected to the I'm just going to move that right here. Let's just make it nice and pretty. All right. So the D is sitting at 0 because it's connected to the ground through the resistor. No problem. All right. So if we make it up and down, high or low, it is not going to make any difference until we press the enable. So now the D is data sits at 0. We capture that. Well, we still capture the 0. Right? Until we change the data bit to 1, and we can capture that by pressing the enable pin. Oh, now we have captured that, and that's it. So it only works when the enable is triggered. Okay, so now this is called a D latch because here's the D stands for data, here is the enable pin, and what is it making a latch? Because we can make it stay that way. All right. If we had the enable pin tied high all the time, then we could just keep pressing this the data input, and the output would just follow the whole data thing. But we can make it stay one way or the other by keeping it not abled until we want this thing to read. So we're going to say, you're going to read this thing when I want you to read, not when you just can, whenever you feel like passing the data. Okay. So again, let's just kind of enjoy watching this whole thing in action. So this D stands at 0. Let's capture the 0, press the enable button. This should stay at 0. Okay, good. All right. And we can just capture that. How is it now? How is it now? Oh, still at 0, because this is still at 0. Okay, how is it now? How is it now? Oh, still at 0. Okay, somebody presses that button, and this data stands at 1 right now. How is it now? How is it now? Oh, it's 1 now. All right. How is it now? It's still 1. It's still 1. Okay. Until we open that and we decide to capture that. So, ladies and gentlemen, this is the idea of a D latch.